We're going to look at interpreting the roots of quadratic equations. Yesterday, we talked about the quadratic formula, and we saw that given a quadratic in the form ax squared plus bx plus c equals 0, we can determine the roots or the zeros using the following formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. In the first example, we're going to use the quadratic formula to solve each of the following quadratic equations. For the first one, we have 2x squared minus 5x minus 3. So we see that a is 2, b is negative 5, and c is negative 3. So we end up with x equals the negative of negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times negative 3. All divided by 2 times 2. Next, we have 5 plus or minus the square root of, so negative 5 squared minus 4 times 2 times negative 3 is 49, all over 4. So therefore, one of the roots is 5 plus the square root of 49, which is 7, divided by 4, and the second root is 5 minus 7 divided by 4. 5 plus 7 divided by 4, that's 12 divided by 4, which is 3, and 5 minus 7 divided by 4 is negative 2 over 4, which is negative 1/2. So we see the following equation has two roots, and if we imagine this to be the graph of y equals 2x squared minus 5x minus 3, it would be a parabola that opens up and has x-intercepts, or zeros, at negative 1/2 and positive 3. Next one. 4x squared minus 12x plus 9 equals 0. So same thing. There's our a, here's our b, here's our c. So we get x equals the negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times 9 all over 2 times 4. So that simplifies to 12 plus or minus the square root of negative 12 squared minus 4 times 9 is 0, all over 8. So x1 equals 12 plus the square root of 0, which is 0, divided by 8. And the second root, x2, is 12 minus the square root of 0, which is 0, divided by 8. And you can see we get 12 over 8, which is the same thing as 3 over 2. And our second root is also 3 over 2. So we get what's called a double root, or we get one solution to this equation. So again, if we imagine this is the graph of y equals 4x squared minus 12x plus 9, it's a parabola that opens up, and it only has one 0. So that means the vertex is the 0 for this quadratic. Therefore, the vertex touches the x-axis. So again, in the first one, we had two zeros. The second one, we have 1 0. Let's check the last one. So in this last one, here's our a, here's our b, here's our c. So we get x equals the negative of negative 4 plus or minus negative 4 squared minus 4 times a times c, all over 2 times 3. Again, if we simplify this expression, we get 4 plus or minus the square root of, well, here we have negative 4 squared minus 4 times 3 times 5. So that's 16 minus 60, which gives us negative 44 all over 6. So our two roots are x1 equals 4 plus the square root of negative 44 over 6, and our second root is 4 minus the square root of negative 44 over 6. When you try to calculate these two, your calculator will give you an error because of the negative 44. If you try to square root a negative number, you'll get an error. So this means there are no real roots. There is no zeros for this quadratic. So to visualize this, imagine we have the equation y equals 3x squared minus 4x plus 5. This is a parabola that opens up, and it never crosses the x-axis. So that is why these do not give us any real roots. So again, if we look at the three examples we just went through, our first example gives us two solutions, or two roots. Our second example gave us one root, or a double root. And our last one gave us 0 real roots. And there's a quick way to determine whether you have 0, 1, or 2. If you look at the square root for each of these examples, they tell you something. So in our first example, we see we have a number greater than 0, and it gave us two answers. In our second one, we had 0, which gave us one answer, or a double answer. And our third one, we had a negative result, and that's why we got 0 solutions for this equation. And notice all those things under the square root come from the b squared minus the 4ac. And that's what we're going to talk about next. So now we're going to talk about the discriminant. The value b squared minus 4ac in the quadratic formula is called the discriminant. And it gives the number of real solutions to a quadratic equation and the number of zeros in the graph of its corresponding relation. So here are the three conditions. The discriminant b squared minus 4ac is positive or greater than 0. Then there will be two distinct real roots or zeros. Distinct means they're different. If b squared minus 4ac equals 0, then there is only one real root, or 0. And if b squared minus 4ac is negative, less than 0, then there are no real roots or zeros. So we have three conditions we're looking at. So the first one is you have two real roots, it crosses twice. The second one, it touches once. And the third one, it does not touch the x-axis. So let's take a look how to determine whether a solution has 0, 1, or 2 answers. Determine the number of solutions for each quadratic. So we have 2.4x squared minus 5.3x minus 3.1. So now we don't need to use the full quadratic equation. We can just use the discriminant, b squared minus 4ac. So that gives us negative 5.3 squared minus 4 times a times c. And all you need to do is type this into your calculator and see what you get. Or realize that 5.3 squared is positive, and negative 4 times 2.4 times negative 3.1 is also positive, so this answer must be greater than 0. But let's determine the value for the discriminant. So for this one I get 57.85, which is definitely greater than 0. So we can say therefore, since b squared minus 4ac is greater than 0, there must be two solutions, roots, or zeros for this equation. Okay, so this parabola, if we were to graph this parabola, it would cross the x-axis twice. Let's try the next one. The next one, notice, is not in our proper form. We need to get it as ax squared plus bx plus c equals 0 before we can use the discriminant. So we have negative x squared minus 7x minus 1 equals 0 if I move all the terms to the left side. And for this discriminant, So b squared minus 4ac is equal to negative 7 squared minus 4 times negative 1 times negative 1. We get 49. Negative 7 squared is 49. And then minus 4 gives me 45. So since b squared minus 4ac is greater than 0, then there must be 2 solutions for this equation. All right, next one. We have negative 3. X plus 5 squared minus 7 equals 0. So first thing I would do is expand this expression. Or first thing most students will do is expand this expression. So we can get it in our standard form. So we're going to use our distributive property. And we end up with negative 3 x squared plus 5x plus 5x plus 25 minus 7 equals 0. That gives us negative 3 x squared plus 10x plus 25 minus 7 equals 0. Distribute now the 3 into the simplified brackets, and I get negative 3x squared minus 30x minus 75 minus 7 equals 0. And one more step, we get negative 3x squared minus 30x minus 82 equals 0. Next step, let's evaluate our discriminant. So b squared minus 4ac equals, we have negative 30 squared minus 4 times negative 3 times negative 82. So let's evaluate the discriminant. And in this one I get negative 84. So here's the case where the discriminant is negative. So since b squared minus 4ac is less than 0, there are no real roots or no solutions for this equation. Now, just as a side note, we didn't have to go through all this for example C. For example C, notice it is in vertex form. And we could have just sketched the graph of this quadratic in vertex form. So we know the vertex is at negative 5 and negative 7, negative 5 and negative 7. And since the a value is negative, the parabola must open downwards. And notice it does not cross the x-axis. Does not cross the x-axis. So therefore, it doesn't have any zeros, or it doesn't have any roots. This one we can complete a lot quicker if we think about graphing the quadratic in vertex form. So last example, the height of a rocket in meters can be modeled by h equals negative 5 t squared plus 180 t, where t is the time in seconds the rocket is in the air. Based on this model, will the rocket reach a height of 1700 meters? So similar to solving quadratics, we're going to let h equal 1700. So we end up getting 1700 equals negative 5 t squared plus 180 t. I'm going to rearrange so that one side equals 0. So if I move everything to the left side, I get 5t squared minus 180t plus 1700 equals 0. So again, this is our A, this is our B, this is our C. We could try to solve using the quadratic formula, but this question is not asking at what time does it reach 1700, it's asking will it reach. So we could find the vertex and see if it's above or below that, but the quickest way is just to look at the discriminant. So if we look at the discriminant, the b squared minus the 4ac, we get negative 180 squared minus 4 times a times c. And if we evaluate the discriminant, we get negative 1600, which tells us there is no solution to this equation, which means it can't reach a height of 1,700 meters. So since b squared minus 4ac is less than 0, the rocket will not reach a height of 1,700 meters. And to visualize that, here is our parabola. Starts at 0, goes up, comes back down, and 1,700 is sitting right up here. So there is no connection between 1,700 and the parabola, so there will be no solution.